Yeah.
So what is Alzheimer's? You might have heard of dementia, but Alzheimer's is a larger domain of brain illnesses that causes dementia. Dementia is more of an umbrella term of a set of symptoms including impaired thinking and memory. Many patients do not actually know that they have Alzheimer's until many years later. It manifests in the body without any noticeable symptoms until the severity increases and it begins to become very noticeable. The patient exhibits behavior causing a loss of memory, inability to do daily tasks, and eventually death. Currently, there is no cure for Alzheimer's, but there are medications that can help the patient and delay the symptoms for a short amount of time, but eventually the disease will take over. The issue that circles around the absence of a cure is that Alzheimer's is not a very well-known disease. It is not as funded as other causes such as cancer or heart diseases. While yes, some money has been given for the Alzheimer's cause, it is still not enough to find a cure. But as it becomes more heard of, the race for a cure is becoming more prevalent than ever. In 2010, Congress passed the National Alzheimer's Act, which declared to find a treatment for Alzheimer's by 2025. Yet the studies still need more funding for the scientists to be able to analyze the situation properly. Over 46 million people are presumed to live with Alzheimer's currently, estimated to rise to 131.5 million by 2050. These incredibly high statistics should be enough to spark a fire under the research community. But there has not been any breakthroughs in years. And while there are medications to help slow its effects, they are expensive and not available to patients in third world countries or patients with insufficient income to pay for it. But scientists have been able to research the process in which Alzheimer's takes over a patient's body and its effects on the molecular level. Maybe with this knowledge and an increase in technological advances, the chances for a cure will rise. Let's explore the discoveries that have been made so far. The main point source of the disease comes from the neurofibrillary tangles and the misfolded proteins, also called plaque. They are both found in the temporal lobe of the brain, where a small organ called the hippocampus is located. This region, often called the limbic system, regulates emotions and is associated with memories. Once the hippocampus is diseased, the patient will show the first notable symptom, memory loss. As the disease persists, it begins to affect other parts of the brain. The front of the brain that controls the process of logical thought is first destroyed. Then the uppermost parts, where the disease will cause paranoia and hallucinations. Then to the back of the brain, where long-term memory is destroyed, thus destroying most all memory together. And finally, the center of the brain that governs important structures, leading to death of the patient. Misfolded proteins occur when another protein in the fatty membrane surrounding the nerve cell gets cut up by an enzyme. This results in beta amyloid proteins. These proteins tend to be very sticky and can easily be clumped or tangled. This can block the signaling and communication in the body, as well as trigger immune reactions that proceed to destroy disabled nerve cells. The other cause, neurofibrillary tangles, are built from tau proteins, which is used in the brain's nerve cells. Normally, it allows the tubes of the nerve system to be straight so that the molecules can move freely. But when infected with Alzheimer's, the tau protein collapses, causing tangles. The tubes then disintegrate, thus denying nutrients from reaching their destination, leading to cell death. There are two ways doctors today can examine a patient to determine if they have Alzheimer's. PET scan is used to find B-amyloid deposits marked by radioactive chemical tags as well as abnormal tau proteins. This data can also be found through a patient's spinal fluid. Although there is no cure yet, here are a couple of medications that are used to slow the process of Alzheimer's. One treatment reduces the breakdown of acetylcholine, which is an important chemical messenger. The disease targets and destroys this messenger, causing the symptoms of Alzheimer's, but the medication helps to reduce its destruction. Another treatment is in the form of a vaccine. It trains the immune system to recognize and attack beta amyloid plaques before they clump or tangle. While these can slow down the effects of the disease, it is not enough to save the lives of the patients living with Alzheimer's. With the increasing number of patients, why is there no scramble for a cure? Unlike AIDS or malaria, there is no real source known to be the cause. Alzheimer is a multifactorial disease. Some factors known are mutations, vascular health inflammation, lifestyle, and possibly viral causes. With all of these possible causes, it is extremely difficult for scientists to make a cure without expensive research. But why isn't the money being put in to save lives? Over 2/3 of people with Alzheimer's live in developing countries, and it is the 6th common cause of death in the US. In a day and age where technology is consistently advancing, I've come up with my own proposal for a possible cure. My treatment, in comparison to the existing medications, will restore the infected proteins within the patient, allowing them to be completely cured from Alzheimer's. To do this, I will transform a malaria parasite, also called Plasmodium, through electroporation, a technique used to increase the permeability of a membrane through an electric field. I will insert an enzyme. This Plasmodium will travel through the bloodstream to the brain, where the misfolded proteins are located. The enzyme is then discharged, and the malaria cell goes through apoptosis, or cell suicide. The released enzyme unfolds the protein, destroys the plaque, and dies. The protein is then refolded correctly. Not only this, but my treatment will be able to travel to these third world countries where the medication is hard to buy and maintain. The use of microneedles, which are about the size of a fingertip, if not smaller, will allow millions of treatments to travel to areas due to their small size, cost efficiency, and easy administration. Microneedles are tiny patches that act the same way as vaccines, delivering a cure via the bloodstream. The temperature will be maintained by a pre-existing medical cooler. Just as scientists today, I was unable to find a perfect cure. My idea came with some possible downsides. The proteins may not refold correctly. Also, the dead nerve cells will be unable to be repaired. While my cure may not completely eradicate Alzheimer's, it is an innovative step towards the future. With the knowledge and funding, scientists must be able to find a cure for this deadly disease before it's too late.